So coming to hydroxyl group containing amino acids, that means the amino acids which carrying hydroxyl group. Okay, the amino acids which carrying hydroxyl groups. So few textbooks they mentioned 2, few textbooks they mentioned 3. Okay, so why? Because tyrosine it is coming under aromatic amino acids. Okay, aromatic amino acids, because it carries aromatic ring. Okay, but a few textbooks they have because aromatic ring in the sense benzene ring. Okay, so which is having hydroxyl group. Okay, phenyl group, right? So this phenyl group is carrying hydroxyl group. So that's why they have categorized this tyrosine under hydroxyl group amino acids. Hydroxyl group amino acids. So mainly what are they? Serine, threonine and tyrosine. Okay, and here also with short letters SCR, THR and TYR with the symbols S. S stands for serine, T stands for threonine and Y stands for tyrosine. Yes, threonine, tyrosine both are starting with T, but tyrosine, the second letter they have taken as a standard letter. Okay, that is Y. So serine, when you come across the structure, it is also a non-essential amino acid. Okay, serine is also non-essential amino acids. Why? Because okay, it also can be synthesized from the pyruvate. Okay, it is also can be synthesized from the pyruvate, and it is having what? It is having alcohol group. Okay, and it's a site for phosphorylation of many proteins. Because of presence of this CH2OH, it can accept phosphate and involved in many phosphorylation reactions. Threonine, serine is a non-essential, but threonine it is an essential. Okay, it cannot be synthesized. Okay, that's why we are supposed to supply this threonine in the diet. Okay, and being what is having, it is also having a alcohol group, so it is also can accepting phosphate group. So that's why this is also site for phosphorylation of proteins. So coming to tyrosine I didn't mention here. Why? Because we will study about tyrosine under aromatic amino acids. Okay, now sulfur containing amino acids. So as like hydroxyl group containing amino acids, the amino acids which are carrying hydroxyl group in their structure. Okay, like this sulfur containing amino acids are the amino acids which are carrying sulfur in their structure. Okay, sulfur in the structure. We do have 2 major sulfur containing amino acids. One is cysteine, other one is methionine. So they are having a standard alphabet, that is C. C stands for cysteine and M stands for methionine. I'll tell you the difference. Okay, cysteine and methionine. So cysteine is a non-essential amino acid. Why? Because if you are having a methionine, automatically cysteine will be synthesized. So that's why non-essential amino acid, cysteine. So another important substance, that means cysteine is another important sulfur containing amino acid. Okay, and there is a one product you will get. Okay, when 2 cysteine molecules are combined, you will get cysteine. You see here the spelling, cysteine. Okay, cysteine and cysteine both are different. Cysteine is having single amino acid, whereas cysteine is having 2 amino acids. Okay, I will draw the structure, the cysteine. So this is one cysteine molecule. Okay, this is one. So this is second cysteine molecule. So what happens? Sulfohydryl groups are there, right? So they make disulfide linkage. Okay, they make disulfide linkage, removing the hydrogen. Okay, you see here disulfide linkage. This is disulfide linkage. Okay, so cysteine is having 2 cysteine molecules locking in disulfide linkage. Cysteine is having free sulfohydryl group. Okay, cysteine is having free sulfohydryl group, but cysteine is having disulfide linkage. Now coming to the methionine, as I mentioned in the beginning of the cysteine. Okay, so cysteine is a non-essential. Why? Because if methionine is there, automatically cysteine will be synthesized. So, but methionine cannot be synthesized in the body. So that's why it is essential amino acids. Okay, and this methionine coded by the codon AUG, that means codon, genetic code. You all aware, right? Genetic code. That means particular amino acids will be coded by particular codon. So all the 20 amino acids, each amino acid is having particular codon. Okay. When AUG comes into the action, methionine will be coded. Okay. And this codon is called start codon. Any protein synthesis, okay, any protein has to be synthesized. The start codon is AUG, that is methionine. Okay. Methionine is the first amino acid used to build a protein chain. You see here the difference between methionine and cysteine. Okay, in cysteine there is a free sulfur group. Okay, free sulfur group, but in case of methionine there is no free sulfur. Okay, which is locked between two methyl. Okay, two methyl groups. Okay, so the linkage is thioether linkage. Okay, the sulfur is locked here. In cysteine there is a free sulfohydryl group, but in methionine there is thioether linkage which is locking the sulfur. Okay, there is no free sulfur in case of methionine.